Hi, I'm Josh Maynard, a student in the mechanical engineering program at UWGB, and this is my project for a GUI. What it does is tells you person inputs the size of their part, the material, and the goal of what they're trying to do to the part, and it tells them if the part is the correct size to be milled, what the spindle speed should be, and what tool they should use. So I'll start off by showing you the code here. This part of the code here is just changing the variables for the boxes where they input the length, width, and height of the part. So it makes it easier to use in the program. Here is where it says if the length is under 36, the width is under 14, and the height is under 16, then the part can be milled, which is what this code right here says, and it will display yes in the box that says can your part be milled. Right here, if any of these conditions are not met, the part is too big, so it will display no in that box. Here again is just renaming different fields, so it makes it easier to write in the code. So this part of the code tells you which tool should be used for what you're trying to do. So the person will pick from the drop down arrow that says either drill a through hole, they want to face the part or make a slot, or they want to chamfer the hole. So right here they pick drill a through hole, for example. It will say in the box that says tool, the output box, it will say they need a drill bit with a chuck. So that's same thing here for facing of the part and mill with collet and chamfer the hole. You need a chamfer with a collet. More renaming. This part of the program starts to say what speed the spindle should be set to. So right here I used a if, else loop. So the material aluminum and the objective is to drill a through hole. So now I used a for loop here so that in the program it shows the minimum recommended speed and the maximum recommended speed. I'll demonstrate that here shortly. So this is just showing text 4 is the label for the speed box and text 3 is the label for the loop, as you can see. So right here x is just set to 1 just so I can multiply it by 1, and so as you can see the minimum speed is 200, the maximum speed is 300, and then the pause here is so that you can see the first all the way through to the last loop. It doesn't just display the maximum value. Same thing here, aluminum, but for facing the part. So as you can see, when you're facing a part compared to drilling, you want the speed to be quite a bit higher. So I used the same loop but multiplied the values by 6 instead of multiplying them by 1. Same thing here. Then this goes over to, now this goes to the cold rolled steel instead of aluminum. So as you can see, the values in the loop get smaller, but the numbers that I multiply by in the program stay the same because the ratio is the same for drilling, facing, and chamfering a hole. Then it goes to stainless steel, more else if loop. As you can see, the loop's values get even smaller because stainless you need to use a lower speed than aluminum or colder rolled steel. And then here's the end of the loop. I no longer have to define these variables with the else if. I can just put else because this is the only conditions that's left. Stainless steel and chamfering is the last one, so I don't need to define that here next to the else. Then right here is the plot of the graph in my GUI at first. So right here, these first two plot commands, they plot the largest that the part can be. So you'll see when I go over to the GUI, there's a box that is the largest the part can be, and then these two plots go to the input boxes of length and width, and it will display the size that your part actually is. And if it's smaller than the other box, you can mill it. If it's bigger, well then the part's not going to fit. So go over to the screen, I'll run the program and show you how it works. So there we go. So right here I'll just start off simple, drill a through hole and material aluminum. So I'll say the length of my part is 30 inches. The width of my part is 12 inches and the height is 8 inches, we'll say. So drill a through hole, aluminum, calculate. So as you can see, the speed right there, it started at the lowest speed, went up to the highest speed. Can your part be milled? The answer is yes, it's within the correct size. And the tool that you're going to want to use is a drill bit with a chuck. So as you can see here, the solid black line, as I displayed here, the solid black line shows the maximum size of the part that can be allowed, and the red dash line shows the size of your part that you're trying to mill. So as you can see, this is clearly inside of that line. So I'll run the program once more and show again what can be done. So for example, I'll say chamfer the hole and stainless steel. And this time I'm going to make the part bigger than the allowed size. So I'll say 38 and 20. Then the height can be 10, which is still inside the okay height, but you'll see. Can the part be milled? No, because as you can see here, the line at 20 and then 38 is clearly too big in the width and the length field. So can the part be milled? No. There, right there, that's where they should see that, and they should stop. So that's the gist of my program. As you can see, there's aluminum, stainless steel, cold rolled steel. Drill a through hole facing the part and making a slot, and chamfer the hole. So that is what the program can do. I would assume if there was a program used like this, possibly in a high school metal shop where kids are still learning, this would prevent things from being broken that don't need to be, or maybe even someone getting injured if something that serious broke. So that's why this program, format of where this program could be useful. Thank you.